So trig problems are always going to be equations. And what I think is the best way to always start out is the trig function and the angle. In other words, you're not going to solve this one by starting out x equals. I mean, you could, but
Okay.
that's not the easy way to do it. So something of 54 degrees. Which trig function of 54 degrees are we going to look at? Of your three primary, are we going to use sine, cosine, or tangent?
Does it matter?
Yeah, because they only give us two pieces of information. So you always want to use the trig function that relates those two sides. In other words, we don't have a hypotenuse. So we wouldn't want to use sine, we wouldn't want to use cosine. But tangent is what relates the opposite to the adjacent. So I'm going to always start out my equation with a trig function. And then what does that equal to?
That equals,
Well, just reading off of the triangle, what does it equal to?
34 over x.
No, opposite over adjacent.
Okay.
Okay? And it's as simple as that. In other words, once you've set up the equation, you've 90% solved it. Now, x is going to equal 32 times the tangent of 54. Do you have your calculator in front of you?
Yeah.
Let's get a number on that. Round it off to the nearest tenth, and let's make sure we come up with the same numbers.
I got 46.8.
Hold on. Mine automatically gives you the radical answer, which is really interesting. What'd you get?
46.8.
46.8. Okay. And you did that on your TI 84?
Inspire.
Oh, you did it on your Inspire. How come I had troubles with that? Just a second. I did 30 times the tangents of 54 degrees. Now, how come when you did it, you got a number and I got a radical answer? How do I...
do you have to change it from radians to degrees, I think?
No, I'm in degrees, but it still gave me a radical answer, and if I hit it again, it just gives me the same thing if I hit control. Oh, 41 point... What'd you get?
I got 46.8.
I got 41.3. And I know I'm in degrees. Why don't you check yours again? Check tangent of 45. Make sure you get 1.
The tangent is of 54.
I know it, but I don't know what the tangent of 54 is. I know what the tangent of 45 is. I'm just trying to figure out why we're getting different answers here. We should get the same answer, and the only reason I can think of is because one of us is in degrees and one isn't.
Well, tangent of 45 is just 1.
Okay. Now do 30 times tangent of 54. Enter.
I got 41.3, but shouldn't it be 32 feet?
No, it says round it off to the nearest tenths.
No, because if it's x over 32.
Right, which means that x is, my apologies. My apologies. Sorry. I was doing the whole thing using the number 30 instead of 32. And that explains why we were getting the incorrect answer. I was getting the incorrect answer. You were doing it fine. Okay. Sorry. All right. So in this one, what trig function do we want to use?
For 38.
38. Uh-huh.
Okay, so we want to use.
In other words, which trig function relates to the angle of 31 degrees, 3, and y?
Cosine?
Yeah. So what's the equation?
That would be cosine 31 3 over y.
Equals 3 over y. In other words, an equation has to have an equal sign in it. Okay. And now how do you solve that?
You multiply both sets by y.
Okay.
Because,
Then what?
it's 3 divided by cosine 31 equals y.
Okay. Sounds like you know how to use your calculator, so you can go ahead and get that answer and put it down there if this is your homework, but I'm not going to verify each one.
Okay.
Especially when I wasted 5 minutes verifying the first one because I was doing it wrong. Okay. What trig function here?
It'd be, okay,
So start with the angle. The angle is z. The sides that they give you are opposite and adjacent. So what's the trig function?
the inverse tangent.
Well, let's start with tangent of z. Whatever
Okay.
z is equals what?
7 over 6.
Yeah. And then what that means by definition is that z equals the inverse tangent of 7 over 6.
Okay.
How much have you had inverse trig functions?
A little bit.
Well, you know that the sine of 30 degrees equals 1/2, right?
Yeah.
We're always taking trig functions of angles and we're getting ratios. By definition, if this is true, then the inverse trig sine of 1/2 equals 30 degrees. We take
Okay.
inverse trig functions of ratios to come up with the angles. So when you're solving for angles, you're almost always using inverse trig functions. When you're solving for sides, you're usually using trig functions. Okay?
Okay.
But that's basically what it means. Another way to look at this is if we have the top one, we can take the inverse tangent of both sides.
Okay.
Just like any equation, you can do the same thing to one side as long as you do it to the other. And then when you have the inverse tangent combined with the tangent, you have z. Or vice versa. If I had the tangent of the inverse tangent, I would have whatever that letter was. So z is equal to the inverse tangent of 7 over 6. This time I am going to do it because we haven't done one of these. So tell me what the inverse tangent of 7 divided by 6 is.
49.4.
Okay, what's our equation going to be in 40?
40 would be
Which trig function relates 70 degrees to that side and this side?
sine 70 equals v over 10.
Okay, so V is equal to,
V is equal to 10 times sine of 70 degrees.
yeah, and you can do that in one step on your calculator. Go ahead and, type 10, multiply, and then sine of 70.
Okay. Get 9.4.
Uh-huh. And 41. Don't try to immediately put it in an inverse. In other words, if you start all of these out exactly the same, you can solve them all. You'll eventually get to the inverse function. But what trig function? Let's start with the trig function. What relates the adjacent side to the hypotenuse?
Cosine.
Okay, so what's my equation?
Cosine equals
Cosine of W. Remember, you always have to take the trig function of an angle.
Okay. Cosine of W is equal to 31 over 37.
Which means W is?
W is the inverted cosine of 31 over 37.
Right. Just make sure when you do it on the Inspire that you have parentheses. It actually puts both parentheses in there when you hit inverse trig function. So it doesn't even let you make a mistake. Not like the old Texas Instrument 84 did. In other words, you had to add that second parentheses, but you don't with the Inspire. Now, what'd you get for an answer there?
I got 33.08.
So 33.1, since they want you to round it off to the tenths.
Okay.
Okay? Now, always know something. Sines and cosines, it's impossible to have the sine of an angle being 1.1. In other words, all sines and all cosines all result in answers that are between -1 and +1. So if somebody tells you this, that's impossible. Cannot be.
Okay.
Okay? In the same way, when we solved for W here, it could not be an angle greater than 90 degrees. Not if that's a right triangle. There's our 90-degree angle. That only leaves a total of 90 for that one and that one. So both of these have to be less than 90. And that's always a good little check to make. In other words, it will catch a lot of math errors if you do those kind of little checks. Trig function here.
That'll be sine of 69 equals 22 over m.
Over u, okay.
Okay.
Which means u is equal to 22 divided by the sine of 69. And that's another one you can put in straight into your Inspire. Okay. .43, the equation.
That one will be V equals
Hold on.
18.
43?
Oh, yeah. Cosine of V equals 18 over 25.
Cosine R, but that's okay. Which means
Whoops.
R equals,
R equals the inverted cosine of 18 over 25.
and what'd you get?
I got 43.40.
Okay.
I just got 44.
Okay. And that's less than 90, so that's in the ballpark. In other words, once again, you wouldn't want to get an answer of 91 degrees there. 44?
See. This one will be that'll be the tangent of 24 equals 17 over s.
Good.
And then inverted tangent of
Hold on. No,
okay.
you don't need to use the inverted. We're only going to use the inverse trig functions when we're trying to solve for an angle, not a side. Okay. In this case, we're solving for a side. The angle's already solved for us. So at no point are we going to need the inverse trig function here. If we solve this equation, we get s equals 17 divided by tan of 24. But notice no inverse tan is needed.
Okay.
You only use inverse if you're solving for angles. Trig functions are of angles resulting in ratios. Inverse trig functions are of ratios resulting in angles.
All right.
Equation for 45.
This one will be sine of 53 equals t over 47.
Which is particularly easy because it's only one step. Multiply both sides by 47. Okay. Blow this up a little bit and see if I can make out this. All right, these word problems are always, and I don't know that I've ever seen them not be, merely right triangles. So we have to be able to draw the right triangle that fits this picture.
Okay.
Well, an escalator looks like that. This is the first floor down here. This is the second floor up there. Well, we don't need the second floor, but we need a right triangle. And they're saying the angle of elevation is 41 degrees. That's that angle right there. That's the angle of elevation. If I was measuring from the top down, theta would be the angle of declination, I think is the word. So if you're measuring up, this is the angle of inclination. If you're measuring down, it's the angle of declination, I think. For some reason that word doesn't sound right to me. But, okay. If the length of the escalator is 28 feet, and that's not the length from here to here, but the actual length of the escalator, this is the escalator, the hypotenuse, find the distance between the two floors, which is y. Okay? So we've taken their word problem and we've drawn it so that it's now exactly like one of the problems any of the 6 previous problems we've done. So what's the equation that applies here?
The cosine of 41
Hold on.
equals x over 28.
What relates the 41-degree angle to y and 28?
Oh, sine.
Always taking signs of angles, and they're equal to ratios. So y just becomes 28 times that.
Okay.
That's the height between the 2 floors. Go ahead and get that number. Let's just make sure we have a number that's reasonable. We wouldn't want a number that said 2 feet, and we wouldn't want a number that said 100 feet.
Okay.
What's 28 times sine of 41?
18.3.
Okay, that makes sense. That sounds like a distance between 2 floors. Oh, it's the angle of depression, not the angle of declination. However, before we go on, let's look at this last problem.
Okay.
And if I'm drawing this picture, notice that the angle of depression happens to be, in this case, the same as the angle of inclination, because this line is parallel with that line, which makes that 41 and that 41.
Okay.
Okay? So know that the angle of depression is usually the same as the angle of inclination, depending on where the person measuring it is standing. You know, if my surveyor is up here, he's going to call it the angle of depression because he's looking down with his tool and he's measuring 41 degrees there. But if my surveyor is down here with his surveying equipment, he's going to point it up and measure an angle of inclination. So to draw the picture here, the top of a slide, well, there's the slide, is 12 feet from the ground and has an angle of depression of 53 degrees. What is the length of the slide? Tell me how to draw the rest of this picture.
So the 12 feet is where the right angle will be.
The 12 feet is, there's the top of the slide to the ground, so that's 12.
Yep.
Okay, so now we have our triangle. Where's my angle of depression?
The top right is 38 or 37.
Actually not. In other words, the angle of depression, you have to kind of draw an imaginary line that's parallel to the ground. Remember that the person pointing his surveying equipment is measuring that angle right there. So the angle of depression is 53 degrees. But from geometry, that means this angle is what?
53.
So now we can make, in other words, we can't immediately put the angle of depression inside of our triangle. Well, I guess we could. We could draw the triangle like this. In other words, I could have done it like this. It's just not as sensical. That's 12 feet. And you're trying to solve for x. But it works actually just the same. The whole point is how to make sure you draw that angle of depression properly. This actually gives you the same exact equation as the way I was going to do it when I had it like this. What's my equation?
Okay. Sine of 53 equals 12 over x.
Correct. Now this one's a little more difficult to solve because it's two steps. I can't solve that in one step. I have to multiply both sides by x, and then I have to divide both sides by the sine of 53. So that's what you want to put into your calculator to come up with x. What do you get?
15.
Good. Again, you don't want to get a number like 150 or anything less than 12. Always remember the hypotenuse of a triangle is the longest side. So if you come up with a solution to a triangle where the hypotenuse is not the longest side, you've made a mistake. Not that I'm expecting you to make mistakes, I'm not. It's just that I really firmly believe that the way one should do math is to always do these little ballpark checks, is what I call them. Okay.
Okay.
Okay, so the chairlift is 2,000 feet long with an altitude change of 939 feet. What's the angle of elevation? So we know it's a triangle. There's the top. There's the chairlift as my hypotenuse. Tell me how to draw the rest of this triangle.
Okay. So
What am I going to leave?
2,000 is the hypotenuse.
Okay.
And then on the
Vertical distance is what?
939.
And do they mean angle alpha or do they mean angle beta?
Alpha.
Correct. Because what they're really talking about is this angle here. That's the angle of elevation. Well, not really. I suppose if you're looking at it from the bottom of the ski lift, it's clearly alpha is the angle of elevation, right? So what's my equation?
A equals...
No, always begin with a trig function. Always. I mean,
Sine...
I understand you're skipping a step, and that's fine. Once you get good at this, you can skip steps. But it helps if you don't skip any steps. So the sine of that angle is equal to what?
Sine 939 over 2,000.
So alpha, the angle itself, which is what they're asking for, is what?
The inverse sine of 939 over 2,000.
Does your class use this terminology? Do they use arc at all? Do they say arc sine ever?
No.
Arc sine and inverse sine mean the same thing. Just like arc tangent, arc cosine, inverse cosine. Same meaning. I can write it like this. That means the same as this. Just so you know.
Okay.
Okay? And that's clearly going to give you an angle, not a in other words, that answer is going to be in degrees.
Yeah.
All right. Good stuff. Mark, I will talk to you on Thursday.
All right. See you.